Any lab stockroom, you'll find at least one mechanical stir because it is a necessity for large-scale reactions or viscous ones. Now, the most common kind of stir paddle you'll find nowadays is the stainless steel shafted Teflon-coated ones. Now, the problem is that this Teflon is not actually coated on there. It's a Teflon tube, and it does not seal very well. I would know, because these tend to cross-contaminate your reactions if you do not clean them very thoroughly. And also, they do not seal very well under a vacuum. And also, when rotating, they do not seal very well under a vacuum because you wear a groove down into Teflon. And I'm using these fancy bearings, not the cheap ones. And there are problems with both, which I have not seen anyone solve. Now, alternatively, you can use a glass-shafted stir, and those are still quite common. But again, the O-ring, it is an O-ring, but you still do have to have a tiny bit of lubrication because it's a rotary seal. Now, you can also get the ground glass ones, but those need even more lubrication. So, I present to you the whip stir. This is not my own design, by the way. I saw this somewhere else, but I don't think many people are aware of it.
So to construct this thing, all you need is a little bit of Teflon tubing, or preferably PFA, because it's easier to work with. So here I have a piece of small diameter thin Teflon tubing, which is commonly sold as a boat and cable for 3D printers. And as you can see, this takes a couple tries to seal, because Teflon really isn't a thermoplastic. This is why PFA is better, because it's a lot easier to work with. But with a few attempts, eventually you can get it to seal. And optionally, you can get a piece of glass tubing to feed this steel wire through. And this is in case you're, running the stir through a Kleisen adapter or a distillation head or some other thing that has a bit of height in it, and that's to keep the thing straight. However, it's not strictly necessary. And then, of course, jam Teflon into the other end. And all this simply fits into a thermometer adapter. Now, the beauty of this is that there is no rotary seal. You can see the operation right here. The Teflon is simply flexing around in a cylindrical manner. So let's get this chucked up in the stir, and you can see it's very effective. It's very vigorous too, because it's whipping the solution around. And here you can see this part does not spin. The Teflon, the glass, they're not spinning or rotating. So this thing will seal perfectly under a high vacuum. So this is suitable for vacuum distillation, whereas a stir bar might not work through a heating mantle sometimes. And you can see the utility of this is that you can simply bend it to a different size, and it will fit any size of flask. It will be easily adjustable. Here you can see it's a bit too long. Well, you simply pull it out a bit. Though be careful to not have the wire jammed in your stir, otherwise it will, kind of poke open the end of the Teflon. And here you can see that the height and vigor can be adjusted while in motion. I don't know any other stir that you could do this with. And that means it's very useful for scraping the walls of a flask. And here you can also see that it works on a very large scale, or at least decently large scale. 3 liters is not too large, but you get my point.